Welcome. In this part, we will continue with integration rules, and here we will extend this to some elementary integration operations. Okay, so we will understand again the fundamental of integrations. It will be a refresher or new to you if you didn't take Calc 1 and Calc 2, and for both of you who took Calc 1 and Calc 2, it will be a good preparation for FE exam. So let's look here what we have. So this is some elementary integration operation. Uh, we Let me use so we have like integration with constant. We've seen this. I mean that we did this. Like if you have a constant, you take the constant out. Separation of terms. Like if we have multiple terms, you can integrate each term individually. Yeah. So we have seen this. Like you integrate f of x and you integrate also the g of x. Yeah. Integration by recognition. We did this already. Like if you have a function and the derivative of this function, so that will give you len of this function. So that is also another integration operation, like integration, like a method or like a trick you can use to solve integration problems. And integration by parts, this is like be like a new topic that we will be covering here. Okay, and integration by part. I'm covering this topic only for those who want to prepare for the FE exam, but it will not appear in. It will not be in the homework. It will not be in the exam. But so basically, this is just for those who want to prepare for FE exam. But this course, because I don't want this to be like a math course, this is not really the emphasis. So this will not be either not be in your homework, not be in your final exam. But I will still cover it for if you want to prepare for FE. Okay. So let's start with this one, like with the separation of terms. Yeah. So with this one, we had we did this. We've seen this before. Yeah. So we have like if this is like my f of x, yeah, and then I can say like the integration of this guy, yeah, 1 over 3x minus 7 dx, yeah. So I can and and we know that this is like you integrate this guy, you integrate this guy, you integrate this guy, and then you put a constant at the end. So that would integrate this guy, that would be x to the power 3. To integrate this guy, that would be x to the power 6. That would be minus 7x plus c. Yeah. So there's nothing new here. This is called this is called the separation of terms. Yeah, this is called separation of terms. Okay, so let's take this to like a problem like this. Can we use the separate? So this is an FE exam problem. So can we do the separation of terms here in this one? Yes, actually, we can do separation of terms here uh, because we can use long division here to separate the to do some separation so that we can basically like use this rule. Yeah. So that's basically like how you can solve a problem like this. So you just like use long division to separate this x, for example, yeah, to get this 4x or whatever out, then you will have this function and whatever its derivative will be, and then you can do the integration. Okay, so how do you remember like long division from your algebra course? So if you don't remember it, that's basically how you do like the long division. So you put here your numerator. So you put your numerator here, like plus 5. You put your denominator here, yeah, and then you divide this guy by this guy. So when you divide, so you divide like this guy here, yeah, by uh, the, by uh, by this guy here. So like if I divided 4x by 2x, what do I get? I got 2. Yeah. So 4x divided by 2x, 4x divided by 2x, you get like 2. And then what you do, you multiply 2 times your do your donim don domin dominator. It's difficult for me to pronounce this word. Dominate do nominator dominate. It's difficult for me to pronounce it. Anyway, you multiply this guy by this guy, so you got here 4x minus 2, and then you subtract like this. So it's like division, but this is called like long division. So basically, so this 4x minus 4x, you got 0 here, and 5 minus negative 2, so you got plus 7. Okay, so what does this mean? So my long division basically, so this is the remainder, yeah. This is called like the remainder, yeah. So my long division basically would be 2 plus, this is the remainder over this guy, yeah. So basically I was able here, yeah, to, that would be like my function here. So I can do this, yeah? So let me write everything down again. So f of x is equal to the integral of 4x plus 5x minus 1 dx. This is equal to the 2 plus 7 over 2x plus minus 1 dx. And then now here I can integrate. Now I can do separation of term, like I integrate this guy and I integrate this guy. So let's just integrate like these two guys, yeah? So f of x, 2 dx, that's like 2x. How about the integration of this guy? Like how could I integrate this guy? Remember, if you have a function, which is here, and its derivative, you, like this is the function and this is the derivative of the function, then you get ln x. So can we do this? Yes, we can do this. So I can, 7, that's like a common factor. I can take this out. So 7, I take 7 out. And I need to put like 2 here. Yeah. So I divide by 2 because like this 2 can go away with this 2. Yeah. So I just divide by 2 here. And I put 2 here. And then, let me just write this. So that's the integration of, so I got the 7 out. That's like a constant. So we got this out. I put this 2 here, which is divided by 2, and then I got like 2x minus 1. And so basically now we have this formula, yeah, which is the function 2x minus 1 and its derivative, which is 2x, because the derivative of 2x minus 1, that's 2, yeah. And that would be equal to what? That, and here like this is like a plus a constant. So that would be equal to what? So now my function would be like 2x plus 7 over 2. When you have like a function over its derivative, that is equal to ln 2x minus 1, yeah, plus c. Okay. Uh, and we have seen this before. Like we have uh, uh, basically we have seen this before because we have seen that. Uh, remember, like we just did it here, like using this rule, like But we can also just check our tables before, because like remember in our tables before I told you the integration of a b plus a x b, that is equal to 1 over that is equal to 1 over a len. We did this in the previous lesson, a plus b. Do you remember? Like we did this before. That's the same here. So here I am integrating 1 over ax plus b. That is equal to 1 over ax plus b here. Yeah, that is the same formula as this guy, and that would be equal to something like this, which is what we see here. So a 1 over a, which is 2 over this. Yeah. So that is like so like you can solve, like there are many ways to solve the same problem. You can check your tables, or you can just do these tricks that I'm showing you here. But for this one, you need to do this long division to get something that looks like this. Okay. I have another problem here. Try to solve this on your own. Yeah, try to solve this problem on your own. And that's again an FE problem. And check your answer. So that's like the answers that I got here. I think some of you asking me for more practice problems. I put more practice problems so you can try solving this one on your own. And this is try to solve it in your own. That's the solution that I got for this one, if I did it correctly. And I will do this in the tutorial. I will show you how to do this step by step in the tutorial. Okay. One more thing I would like to cover here, it is called like integration by part. This is used to integrate the product of two functions. So I have a product of two function, and this is like how you do it. Yeah. So this is like you take this as your first function, you take this as your second function, and then you expand it in this way. Okay, so where u, that's like your first function, v, that's your second function. Now, the question is like how to choose like your u and how to choose the v. You choose it in this order, but this is not important now because that will not be clear without seeing an example. But that is basically how to choose your u and dv. So you start by this order. Yeah. So uh, so when you choose like your u function, prioritize what appear here first in this list first, and then whatever is like the remaining part would be like your dv function. But I mean, all this is not clear, yeah, without seeing an example. Like so, when we see an example, that would be very clear. So this is an example. Yeah, we in the previous lesson we already know that this guy already has like one of these ready use functions that I can use to find like the solution of this guy. But we're not gonna do this time. This time I will do this using integration by part. And again, integration by part, this is just for those of you who want to practice for FE exam. It's not going to be in your homework. It's not going to be in your exam for this course. This is just for practice purpose. Yeah. But I encourage you, of course, to watch it. Yeah. Even if you're not planning to take FE exam, you can watch it. Yeah. But okay, so let's just do it. Yeah. So again, we have like two functions here. I have like this guy and I have this guy. So one of it need to be my u function and one of it need to be my dv function. So one is u and one is dv function. And how to which one should be my u and which one should be my dv? Like you go to this list here. So the ones that appear first in this list should be your u function. So this what appear first, like x, like this algebraic function x squared, blah blah blah. This appear before this, so this should be my u function and this should be my delta v function. That's basically how you do this. So now I know this guy appear first, so that would be my u function. Yeah. I'll call my u function is equal to this, and my dv function, that would be equal to this guy here, dx, whatever is remaining. Yeah. So now I have my u, and now I have my dv function. What should I do? So see here, I need to have it in this form that I see here. So that is, let me make it again clear. So this is u, and this is dv. Okay, I need to express it as like my u and v. So that means I need like to integrate this guy. And then I need to express it as my du, which means I need to differentiate this guy. So let's just like differentiate this guy, like du with respect to dx, that would be equal to 3. Yeah, which I can say like du is equal to 3 dx. Yeah, so here I did this. So now do I have, yeah, so I have du, yeah, which is equal to 3 dx. Now I have this guy here. I have my u here, so I have this guy here. So I have this guy, which is this guy here. I have now this guy, which is this guy here. Now I need to get like this guy and this guy. So which means that I need to like integrate this function. So dv over dx e to the power x. So that's my derivative. I need to integrate this function. So when you integrate this function, the integration of ex e to the power x is also e to the power x. So now I have my v function. Okay, so I'm good. Yeah, I'm really now on. So let me write this down. So my u dv is equal to u v minus v du plus constant. Okay, so let me write it down. So my u, what is my u? My u is like 3x. What is my dv? My dv is e dx. Yeah, that's equal to u. What is u? 3x times v. This is v. What is v? That is equal to 2x. Yeah, minus v, which is negative v, which is like this guy, ex, uh, time du, which is 3 du here. That is like, this is du, 3 dx. Okay, so let's see what we have here. Okay, so we have here, let me simplify this a little bit. So we have here 3x e to the power x negative. I can take the 3 here as a common factor, and this plus constant, yeah? Don't forget the constant. So as a constant, I can take the 3 out, and I have to ex dx. Have to integrate this with respect to dx. And what is the integration of this guy? That's again, that is, so that will give me 3 ex negative. The integration of ex, that's again ex. Remember, like from the previous lesson, that is like ex here, okay, plus the constant, okay. So can I simplify it even more? Yes, I can simplify it more. So I can say like this is 3 ex x minus 1 plus c. So let's just see what we did here. So what we did here, I'm telling you the integration of 3x 2x dx is equal to something like this. Have we seen this before? Yeah, this is in the previous lesson. Let me show you the previous lessons what we did. Uh, where we did this before. So this was we do this. Yeah, here we go. Let me just copy this guy and paste it here. So this was from these special function or like these things that I showed you like in the previous lesson. So here the 3 is a constant here, so I can take this guy out. So this is not important, but x e to the power x dx e to the power x dx, that's equal to this guy. K here in that case is like equal to 1. So I got like, so this is the 3 and I got what I got here. Like k here is equal to 1, k here would be equal to 1. So I got what I have here. And the previous lesson I just showed you already made function. But how did we reach this conclusion? How did we reach this solution? Basically, we reached this solution through integration by part. That's how we evaluated this guy as this guy through integration by part. So here I'm just showing you the steps in this video. Okay. So basically, I think that's all. Like here, if you want to do more practice, so please try to practice this on your own. So this is easy. This is a function and its derivative. Uh, this is from like the tables that you did before. You can like check this in the table and do it. And here, this is part is integration by part. So you have like the function, like two functions. One is x and the other one is sine x. So for this guy, like for this guy, you use this guy, yeah. For this guy, you use this guy, and for this guy, you use so for your exam, like in your exam or your homework, you can get this guy, you can get this guy, you can get this guy. I will not give you this guy in the exam or the homework. Okay. So this is for the practice. This is the solution. Here is this is practice for integration by part. Again, if you want to practice more, so here that would be like your u, and that would be like your dv. Yeah, just like u, and that's this guy is like the dv, and then you can sorry, yeah, this, and then you can do this only for those who want to practice for the FE exam. It's not going to be in the homework or the exam, this exam. Okay, and this is the solution. Okay, we did this already, and then finally, and then like once you do this, then you are ready to do your homework problem. Okay, and the homework problem will not include the integration by part. Okay, so that's it for this lesson. I think it was a little bit of a short lesson, but I will see you in next lesson, similar to what we did with differential calculus. Like we started by these uh, general rules, and then we went to higher order derivatives. Also, we here are going to higher, like next lesson would be similar, like I'll go to higher order integrals. Okay, so see you next lesson.